Alright, hi everybody. Here is your video key to problem set 1.1b, point, line, and plane postulates. As you can see, I have the split screen with GeoGebra so we can see the postulate, and then I'm going to draw it in GeoGebra for you. Okay, number one, it says, through any 2 points there exists exactly one line. So if you draw 2 points, I'm actually just going to use the line tool here, if my Apple Pencil would work. And then you'll see that through that line, or through those 2 points, there's only a single line that can be drawn. There we go. Apple Pencil's working. And so there's our 2 points on a line. Now really there's more points than that on a line, which we'll get to in a second. But I can't draw some other line that passes through those 2 points. So that can't happen because that's not a line. So if I drew another line that passed through those 2 points, it would be the exact same line. I kind of missed there, but hopefully you get the point. Let's see. I think this one will do it. I missed there a little bit too, but you understand the point, hopefully. Okay. Number two, a line contains at least 2 points. Well, same picture, really. Here's a line, and there's 2 points on it. We got a point right here and a point right here. But again, there's actually infinitely many points on a line, but this postulate just says that there has to be at least 2, which is true. But really, these are all over the place. I can't even fit them all in there because there's so many. Okay, so that's what's going on number 2. Number 3, if 2 lines intersect, then their intersection is exactly 1 point. So let's draw 2 lines, and we'll see this illustrated right there. And then there's where they intersect, and they intersect at a point. Okay, so when 2 lines intersect, they intersect at a point. Number 4, through any 3 non-collinear points, there exists exactly 1 plane. So down here, there's a freehand shape. So you can use that tool, which I newly discovered. And you can draw like your own shape here. And so there's my plane. And then as long as there's 3 points that are non-collinear, then there's got to be a plane for those 3 points. So through any 3 non-collinear points, there exists exactly 1 plane. And this, I was talking to one of my classes, how if you ever sit on a 3-legged bar stool, assuming that the floor is perfectly flat, therefore your floor would be a plane, a 3-legged bar stool can never wobble because the 3 points, which would be the feet of the bar stool, have to all sit on the floor the same way. And so they're all laying on the same plane, and so a 3-legged bar stool will never wobble. But if you have a 4-legged bar stool, that could wobble because you can have a 4th point that doesn't have to be on the same plane as the other 3 points. So even though 3 points of a bar stool could sit on the floor, the 4th one wouldn't have to, but the other 3 do. So through any 3 points, there exists exactly 1 plane, as long as they're non-collinear. And then this one, the next one, number 5, says a plane contains at least 3 non-collinear points. So it's kind of very similar. So here's a plane, and it has to have at least 3 non-collinear points. Again, it can have more, and it does have more. It really has infinitely many. We can do this forever, but it has to have at least 3. Number 6 says if 2 points lie in a plane, then the line containing them lies in the plane. Well, that's fairly obvious. Here's 2 points. Let's draw a line through them. Okay, I kind of missed, but it's close enough. Certainly, if 2 points are on a plane, and through any 2 points you can have a line, then that line must also be in the plane. And so that's what's going on in number 6. And number 7 says if 2 planes intersect, then their intersection is a line. This one was the hardest one to draw, but if you can draw like a 3-dimensional cube here, oh, I thought that was a circle. Wow. Come on. There we go. And then if I draw this, like so, that's pretty good. Let's see if it'll like this side. Nope. This one's the hardest to draw. We'll give it one more shot. Okay, and then I'm going to just use the pen. All right, so there's a cube. But if we just look at the front face, like this face here, and the top face, you can see when they meet each other right here, that they do in fact form a line. And so that's kind of the easiest way to draw it. And there you have it. Those are the 7 point, line, and plane postulates of problem set 1.1b.